Hi everyone, welcome back to my channel. This is Mr. Bodehas, your online math teacher. In today's video, you will learn how to solve arithmetic series. Arithmetic series is the sum of the first n terms of an arithmetic sequence written as S sub n is equal to a sub 1 plus a sub 2 plus a sub 3 up to a sub n. You just have to add all the terms in a given arithmetic sequence to find the series. For example, find the series of the first 5 terms of the arithmetic sequence 1, 3, 5, 7, and so on. Here, first thing to do is you just have to find what are the first 5 terms of this given arithmetic sequence. So here, you can find the first 5 terms, of course, by using the common difference, which is 2. You have to add that 2 or the common difference to get the next term. So you have 7 plus 2 is 9, and 9 is the 5th term. So you have already your first 5 terms. Now add all of them to get the series. So you have here the series of the first 5 terms is equal to 1 plus 3 plus 5 plus 7 plus 9 is equal to 25. And that is on how to find the arithmetic series. You just have to add all the terms in a given arithmetic sequence. Now, what if we are to find the first 100 terms in a given arithmetic sequence? Of course, we will not be adding one by one. We have to use a formula, and that is the sum of the first n terms of an arithmetic series. The arithmetic series a sub 1 plus a sub 2 up to a sub n can be solved using the following formula. We have here S sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n. A sub 1 here is the first term, a sub n is the last term, and n is the number of terms. For example, find the sum of the first 10 positive integers. The first 10 positive integers are the following: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. To solve the sum or the series of the first 10 positive integers, we can solve it using the arithmetic series or this formula. Of course, our a sub 1 or the first term is equal to 1, and our a sub n or the last term is equal to 10. And the number of terms in a given arithmetic sequence is equal to 10 also. Now, substituting these necessary values to our formula here, we have this. The series of the first 10 positive integers is equal to 10 over 2 times 1 plus 10. Then simplifying, we have 1 plus 10 is 11, and 10 divided by 2 is 5. Then 5 times 11 is 55. Therefore, the series of the first 10 positive integers is equal to 55. Let's try some examples. Example number 1. Find the sum of the terms of an arithmetic series given that a sub 1 is equal to 6, a sub n is equal to 82, and n is equal to 20. In the given example, the variables a sub 1, a sub n, and n is already given. We can use the formula S sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n. Now, substituting the given or the necessary values, we have a sub 1 is equal to 6, a sub n is 82, and n is 20. Then we get S sub 20 is equal to 20 over 2 times the quantity of 6 plus 82. Then simplify, we have 6 plus 82 is 88. And 20 divided by 2 is 10. Then multiplying 10 by 88, we have 880. Therefore, the series of the first 20 terms is equal to 880. Example number 2. Find the sum of the first 20 terms of the arithmetic sequence 3, 5, 7, 9, and so on. First, determine the necessary variables in the given arithmetic sequence. And we need to find a sub 1, n, and a sub n. From the given arithmetic sequence, it can be observed that the first term of the sequence is 3, or a sub 1 is equal to 3. Also, since we would like to determine the sum of its first 20 terms of the arithmetic sequence, it follows that our n is equal to 20. Now, a sub n is not given, or a sub n is unknown. So, what should we do if a sub n is unknown? Can we use the formula or not? Okay, of course we can use the formula, but we need to find first a sub n. Now, in finding a sub n, we have this formula. A sub n is equal to a sub 1 plus the quantity of n minus 1 times the common difference. So we need the common difference. From our given example, the common difference here is 2. And you know already how to find the common difference. Okay. Now, next we have determine the sum of the arithmetic series. We already have these necessary values here. Now it's time for us to find the sum of the arithmetic series. Since we know already the values of the variables a sub 1 and the common difference, then we can now solve for the sum of the first 20 terms of the arithmetic series using this new formula. This is just a combination of the two formulas, the formula for finding the arithmetic series and the formula for finding the nth term of an arithmetic sequence. Now, let's derive this first before using it. Here are the two formulas that we are going to combine. S sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n, and a sub n is equal to a sub 1 plus the quantity of n minus 1 times the common difference. As you observe, I highlighted a sub n here because that is unknown in our given example. Now, in order for us to get a sub n, we will be using this formula. Now, instead of writing a sub n here, I write a sub 1 plus n minus 1 times common difference, which is this one. Then just copy this, then combine like terms. So the similar terms here are a sub 1 plus a sub 1. So we can combine them. A sub 1 plus a sub 1 is 2a sub 1. Then just copy the other terms. So this is now the new formula. Take note that we will be using this formula if a sub n is missing. Now let's continue. Substitute the necessary values for n, a sub 1, and the common difference. Then we have s sub 20 is equal to 20 over 2 times 2 times 3 plus the quantity of 20 minus 1 times the common difference, which is 2. Then simplify. 20 minus 1 is 19. And 2 times 3 is 6. Then multiply 19 by 2, we have 38. And 38 plus 6 is 44. From here, 20 divided by 2, we have 10. And 10 times 44 is 440. Therefore, the sum of the first 20 terms of the arithmetic sequence 3, 5, 7, 9, and so on is 440. Now, I want you to answer this individual practice for you to check if you really learned from this discussion. And please comment your answer below for me to check as well if your answers are correct. And that's all for today's discussion. I hope you learned something. And thank you for watching.